who are keen to hear from Professor Hughes in as much that what she has to say, and especially the most recent report from the IPCC and its implications, need to be absorbed and applied not only to our community, to our nation as well. And in the midst of all that's going on in the political scene and the lack of direction in terms of addressing climate change in our nation at the present time, we certainly appreciate not only Professor Hughes' contribution, but your enthusiasm as well. Professor Hughes, thank you, Lesley, for coming our way and giving us your background and insights, because your involvement internationally and your expertise is something that we certainly appreciate. We in this particular local government area are very conscious of the fact that we have a lot of issues regarding climate change, not only sea level rises, but also the way the climate is affecting our cities, our planning and our opportunities to protect and secure not only our infrastructure, but the well-being of our people. So tonight, everyone, not only do I welcome you, but also thank Professor Hughes for coming by to give us your insights and your contribution. And tonight, thank you.
Coming out tonight, it's wonderful to see everybody here. My talk comes with a bit of a warning. I'll tell you a very short story. I was out for a bushwalk the other day and bumped into somebody doing some bush regeneration, and I'm a bit of a passionate bush regenerator, so we got talking and he found out who I was and I found out who he was, and he said, "Yeah, I went to one of your talks once." He said, "You're that harbinger of doom, aren't you?" I said, "Yes, that's generally me." And so my talk comes with a pre-apology, because I'm talking about the new IPCC 1.5 degree report, special report. And I'm sure some of you have actually read it. It is a depressing read. I'm going to try and unpack it as well as I can in the next 40 minutes or so. But I will just tell you right now, the news isn't very good. But that, of course, means that it's the efforts of groups like the people in this room that are absolutely so important. So thank you for your efforts. All right, so this is what I'm going to talk about today, and try and put it in the context of other things we know about climate change, especially in an Australian context. So this is the new report that came out with much fanfare a couple of weeks ago. I should also say that while the report is a depressing read, there are quite a lot of scientists that don't think it's depressing enough, think that the IPC is sort of sugar-coated it a little bit. As you will see, there's not a lot of sugar-coating, but there are some scientists out there that think that the warning should have been even stronger. All right, so you're all here because you know that the burning of fossil fuels is driving dramatic changes in the Earth's climate system. As at September this year, we were at 411 parts per million, which is about 30% or more than pre-industrial levels. And we've had about a degree of warming over the last century or so, since pre-industrial times. I'm going to show this little graphic. It'll take a while to sort of warm up. For those of you that can't read all the words, it doesn't matter. Each one of those dots is a country. Australia, and it's in alphabetical order, so Australia's up in the middle of the top row. What I'm going to show you is this rather cute little graphic that will show you the temperature anomalies, that is, the difference between the mean temperature in any one year and the average temperature over the period from 1880 until I think it goes up to 2017. So let's get that started. Just the year is shown up the top. It'll take a while to warm up. So, it's pretty dramatic, isn't it? You can download it free from Flickr if you need to use it in any of your talks. I think it's a great little illustration. So that's what's been happening, and it doesn't matter which of those dots you look at. Basically, it's been happening to every country. So we've got rapidly rising temperatures. Going back to about a century ago, the years below the bar are below average, the years above the bar are above average, and what you can see from this graph is that from about 1980, every single year has been above average, and in fact 17 of the 18 hottest years on record have been this century. Australia is not immune, of course. It's been warming everywhere, though some areas more than others. As you can see, there's a very large red dot of 2 degrees in central Australia. So generally, inland Australia is warming more strongly than the coastal regions. Heat waves are getting longer, hotter and drier. And in fact, we've had double the number of hot days defined as days over 35 degrees now compared to the 1960s. Heat waves actually kill more people in Australia than any other climate-related event. People often don't realise that because heat waves don't leave the sort of massive scars on the landscape that floods or bushfires or cyclones leave, but they're actually far deadlier. If we think back to the Black Saturday bushfires in Victoria in 2009, 173 people died during the fires. Twice that number died from heat stress in the week before. That's just an example of us not really taking heat waves as seriously as we probably should. That picture there was taken in Heron Island last year. We have underwater heat waves, of course. And in 2016, there was the worst bleaching event globally and on the Great Barrier Reef ever recorded. Unfortunately, it occurred again the next year, the first time we've had bleaching in 2 consecutive years, with sea surface temperatures about a degree above normal. Some of my colleagues at the University of Melbourne have been doing what's called attribution studies and have estimated that the bleaching in 2016 was 175 times more likely to have occurred because of anthropogenic climate change. Bushfires. Bushfire seasons are now far longer, hotter and more severe than in the 1970s. This year, in many local government areas in New South Wales, the bushfire season was declared 2 months earlier than the usual official season. We had, in August, 100 out-of-control fires just in New South Wales. Our water cycle is intensifying, and what I mean by that is that areas that are usually pretty dry are getting drier, and areas that are usually wet are getting wetter. We have long-term drying trend in the southwest and southeast of Australia. The Millennium Drought, which finished in 2009, was at that point the most severe drought experienced on record in Australia. We are yet to know how long the current drought will last. When we do get rain, because the atmosphere is warmer, it is capable of holding more water, and that means that when we do get rain, we tend to get more extreme rainfall events, which of course is when we get flooding. Storms. Storms are also more energetic, simply because there's more heat and there's more water in the atmosphere. By 2100, CSIRO has projected that we could get about 30% more thunderstorms than we do at present. Ecosystems, this is of course a topic after my own heart. Just a few quick pictures. I've already talked about coral reefs bleaching. We probably lost about 50%, somewhere between 30 and 50% of coral on the Great Barrier Reef in 2016 and 2017. But it's not just the Great Barrier Reef, it's the most obvious one, but plenty of other ecosystems are suffering. These mangroves, these 2 pictures were taken up in the Gulf of Carpentaria in the summer of 2016. I see Colin Woodruff in the audience somewhere. Where are you, Colin? I just saw you. He's the mangrove expert. These pictures were taken by a researcher called Norm Duke, who happened to be flying over and noticed massive die-off of mangroves up in the Gulf. River redgums, Eucalyptus camaldulensis, the iconic species that grows along the banks of the Murray and along the Murray-Darling Basin, have already been affected by over-extraction of water and salinity, but they are dying in the drought currently. As sea level rises, we have a lot of ecosystems, especially up in the Northern Territory, around the Mary River, Alligator River region, where salt water is simply intruding further inland and replacing freshwater ecosystems. In our alpine zone, we have lost about 10% of our snow every decade since the 1960s, and so those alpine regions are turning into not so alpine regions, and of course that has a lot of impacts on species that need snow for things like hibernation. And of course, with the increase in bushfires, we are now starting to see fires penetrating into alpine vegetation and rainforest vegetation that is not well adapted for fires. This picture here is from the Tasmanian World Heritage Area, where in 2016 in January, fires penetrated for probably the first time ever into these systems, killing trees that were over 1,000 years old. And we are also losing species. This little guy has the distinction of probably being the first documented mammalian extinction due to climate change. It's the bramble-key malomies, or at least was the bramble-key malomies. There used to be several hundred of them in this one location. It doesn't look very hospitable place to live. This is Bramble Key up in the Torres Strait. It's been subject to storm surges and sea level rise, and in 2015 this species was declared extinct. I should point out that it had already been declared as critically endangered, but nobody did anything to move it anywhere else, and we have now lost it. Coastal flooding, sea levels, the rate of sea level rise is about triple what it was in the 1990s. It's accelerating rather rapidly. We've had about a half a metre rise, well, at least we are predicting at least a half a metre rise over the next 100 years, but that's without factoring in what might happen in Antarctica, and if the Antarctic ice shelves collapse the way some scientists think they might, that would be a 2 to 2.5 metre rise by the end of this century. Sea level rise is one problem, of course, but what happens with sea level rise is that simply that greater volume of water, when there is a storm, there's an awful lot more water to come onto land. So we get storms that might have been once in every 100 years occurring once every 10 years or more frequently. Feeling depressed yet? Sorry, I did warn you. Okay, well, a previous IPCC report, both the fourth and the fifth assessment reports, identified Australia as being the most vulnerable developed country in the world to the impacts of climate change, simply because, well, for a whole bunch of reasons, but basically because we already have a highly variable climate system, and climate change is making that more variable. But we also know that the risks could be substantially reduced if we keep warming less than 2 degrees and preferably less than 1.5 degrees. And the Paris Climate Agreement enshrines both of those targets as the ambition to aim for. Remember, we've already had a degree. So what the IPCC special report is all about really is it talks about the difference between what could happen with 1.5 degrees and what could happen with 2 degrees. And I'll show you some contrasting figures for that in a moment. And this, I'm afraid this is the biggest I could get this graph, but for those of you up the back, each one of those bars represents some sort of system. So the first one is warm water corals, they're mangroves, low latitude fisheries, the Arctic region, terrestrial ecosystems, coastal flooding, fluvial flooding, crop yields, tourism and heat-related morbidity and mortality. And basically the stronger the warm colour, the more trouble that system is in. The horizontal lines then show the degree of risk associated with different levels of warming. If you look over there on the y-axis, the grey bar is where we are now, then the next line is 1.5 degrees and the top line is 2 degrees. So as you can see, warm water corals are already in trouble, as I've just showed you, in extremely significant trouble even at 1.5, basically pretty well lost at 1.5, somewhere between 1.5 and 2 degrees in many regions. By contrast, there are other sectors like mangroves that are doing quite well in some places, not so well in others, are pretty resilient systems, though Colin's the expert on that. Things like tourism also have risks. Coastal flooding is another one where the risks are being seen at fairly low levels of temperature rise, but everything gets more risky the hotter that you get. Okay, so I want to show you a few graphics then from the IPCC report, or at least the interpretation of the IPCC report. And basically these are graphics that look at risks and compare them between 1.5 degrees and 2 degrees and just calculate how much worse 2 degrees is going to be compared to 1.5. So for example, that top one is extreme heat. The global population exposed to severe heat at least once every 5 years. At 1.5 degrees, it's 14% of the global population. At 2 degrees, 2.6 times worse at 37%, and so on. So the middle one is sea ice-free Arctic. At 1.5, once every 100 years. At 2 degrees, at least once every 10 years. So that's an order of magnitude difference between that half a degree difference. Sea level rise, not a lot of difference between 1.5 and 2 degrees, and that's because sea level rise is a very slow process compared to temperature. Sea level rise is locked in, but it lags behind temperature by decades, centuries and millennia. So even if we halt warming at 2 degrees, sea level rise will continue to rise, possibly for several thousand years. Okay, species, just a sort of similar way of showing the difference between 1.5 and 2. So the first row is species lost in vertebrates, 4% at 1.5, double that, 8% in 2 degrees. Species losses of plants, 8 to 16%, once again doubled, and in insects, tripled. Various aspects of land, ecosystems, the amount of the Earth's land area where ecosystems will shift to a completely new biome, that is just a completely new type of vegetation, etc. 7% versus 13%. The middle row is permafrost, the amount of Arctic permafrost that will thaw, 4.8 million kilometres squared in 1.5 degrees, 6.6 million kilometres in 2 degrees. And the really important thing about the permafrost is that it's potentially a very strong positive feedback. So as the permafrost thaws, all of that carbon, either in the form of just carbon or in the form of methane that is currently frozen, then gets released. That has a positive impact on more warming. So what happens to the permafrost is extremely important. And then the bottom row is crop yields, and they've just picked the reduction in maize or corn harvest in the tropics, 3% at 1.5, 7% at 2, and of course maize is one of the 3 major crops that keep humans alive. Then in the oceans, this is the final little graphic, coral reefs at 1.5 degrees, 70 to 90% decline, pretty much all of it gone at 2 degrees. And then fisheries declining 1.5 million tonnes at 1.5 and twice that at 2 degrees. Now, of course, there are lots and lots of assumptions that go into coming up with these estimates. They're fairly rubbery figures, but I think you kind of get the idea that a lot of things are in trouble. Okay, so the 1.5 degree report spends quite a lot of time talking about the probability of keeping to 1.5. What is that probability? Well, of course, it depends on lots of things. And this graph, it's a little bit complicated, my apologies, it's from the report, is about some alternative futures that we could envisage. So the black line there is what we've had so far in terms of global greenhouse emissions in gigatons of carbon dioxide equivalents per year. The sort of green and the greenish sort of bottom band is what we would need to reduce by to be consistent with a 1.5 degree future. The yellowy band is what we need to reduce by to be consistent with a 2 degree future. The blue band is the current pledges under the Paris Climate Agreement, which, as you can see, even if met 100%, still get us to well over 2 degrees, probably 3 degrees or possibly more. The grey band, of course, doesn't really bear thinking about, but that is the business as usual trajectory based on current emission levels. So, Paris. Paris was an incredibly important meeting, and the Paris Climate Agreement was an incredibly important international framework. It's not enough at the moment, but the framework is a very, very good one. So emissions projected to 2030 under the Paris pledges, if all met on time, 100%, still get us, as I said, to probably about a 3 degree warming. It's about 52 to 58 gigatons of CO2 equivalent every year. Then what the report does is that it goes through what we need to do, what are the things that need to happen to keep to 1.5 degrees. And it goes through this in quite some detail. I'm going to try and distill it down to the major points. So the first thing it says very clearly is that we require a far-reaching and historically unprecedented transformation of energy, land, urban and industrial systems in the next 20 years. You can all have an idea about how likely that is to happen. Importantly, this is not just all about energy. We tend to focus on energy because it's sort of doable and tangible. In Australia, energy emissions from energy is somewhere between 30 and 40%. That means there's an awful lot of emissions coming from other things that are actually more difficult to control. All of the pathways, and the IPCC report puts ahead, these pathways are basically scenarios for the future with different sorts of assumption. But they all have in common that they have to achieve net zero CO2 emissions by the middle of the century. Without doing that, we're out of the ballpark. They all also don't just focus on CO2, they also focus on what are called short-lived climate pollutants. These are things like methane and black carbon, which is the particulate matter from burning of fossil fuels. They estimate that the annual investment in energy systems to be transformative needs about $2.4 trillion US. And almost all of the pathways require some form of what is called negative emissions technology, sometimes called CDR or carbon dioxide removal technology, by the end of the century. Now, what is negative emissions technology? Well, there's a whole bunch of them. I'll get to that in a moment. Yes, the CDR. So here's a whole bunch of examples put forward in the IPCC report of negative emissions technology, all the way from ocean fertilisation. You can put iron filings in the sea. Iron is a limiting nutrient for phytoplankton. They then go crazy, they draw down lots of CO2, they sink that down to the bottom of the ocean, and they take a lot of CO2, at least for a very short time, in a local area, out of the atmosphere. Others, ocean alkalinity addition, I think that works in a similar way, but I'm not an ocean chemist. Some sort of accelerated chemical weathering of rocks. Once again, I don't really know how that works. Maybe there's some geologists in the audience that might have a view on that. Manufacturing carbonate minerals using silicate rocks and CO2 from the air, so basically sucking CO2 out and putting it into some sort of solid compound. Direct air CO2 capture, so this would be like carbon capture and storage that occurs, that we know how to do in coal-fired power stations. We just can't do it cheap enough or at scale enough for it to be effective. Biomass energy with carbon capture and storage, that is growing plants, which of course do capture carbon dioxide during photosynthesis, using them for energy. And finally, afforestation and reforestation, basically growing a lot more plants to take carbon out. So those are the main negative emissions technologies that people are thinking about currently and experimenting on, etc. We probably actually need to do pretty much all of them. So, basically, one of the big messages in this IPCC report, and indeed all of the other IPCC reports, is that what we do now really matters. The longer we leave it to get serious, the bigger the mountain that we have to climb. So once again, this is a graph. That black line is the temperature anomalies that we've had so far. The blue band is a low emissions scenario. The red band is the high emissions scenario. We are tracking the high emissions scenario currently. In IPCC speak, that's called RCP, or Representative Concentration Pathway 8.5. And for those IPCC nerds in the audience, you will know that that just is a measure of the radiative forcing on the Earth's surface with that amount of emissions. As you can see, the low emissions scenario gets us to 1.5 in a hopeful sort of world. The high emissions business as usual scenario gets us to well over 4. The important thing is that there's a substantial overlap between the results of those two emissions scenarios, at least in the near to medium term. That is, the climate change that we are going to get between now and the middle of the century is pretty much locked in by the emissions that we've already put out there. It won't be till after about the middle of the century where what we do now will really make a big difference. All right, I thought I'd bring it back home a bit now to move away from the global IPCC report and just tell you about some work that the Climate Council just released a couple of days ago. Every year we publish a renewable energy scorecard for the different states. And so this was launched in Perth a couple of days ago, so I just thought I'd show it to you. As you can see, our own state here, New South Wales, has fallen behind a lot of the other states in terms of the percentage of renewables. Tassie, of course, is doing well, and it's always done well because most of their energy comes from hydropower. The ACT is doing fantastically. They're on target for 100% renewables by 2020, so only a year and a half away. So I do think that the ACT, yes, give them a good clap, the ACT does show that you can do it. You know, with the will, the political will, the leadership in the ACT has been fantastic. They've actually talked to scientists. My colleague Will Stephan is on their science advisory group, and they're doing it. We should all be able to do it. South Australia also doing well. This is just some of the details up the back. You probably can't read this, but it basically just shows what all the targets are and how well they're doing, the different states are doing in meeting those targets. And I'll just put up this one, which is more readable, where these are the current state targets for renewables. So you can see they vary quite a lot. Once again, Tassie and the ACT doing well. South Australia aiming for 50% by 2025. Queensland 50% by 2030, despite supporting the Adani mine, so there's a bit of cognitive dissonance going on there. Northern Territory even 50% by 2030, despite their lifting of the fracking ban. Victoria 40% by 2025. New South Wales and WA currently have no published hard targets. So, where are we at? This is my little summary, and then I'm happy to try and answer questions. On the plus side, because there has to be a plus side, otherwise we'd all just give up. On the plus side, we have fantastic opportunities, especially in a country like Australia. We have brilliant solar and wind resources, we have great science, we have a stable democracy, I think, most of the time. So we have an extraordinary opportunity. If we can't do it here, how could any other country hope to do it? Our cities and regional centres will play an incredible role. 70% of the emissions reduction that we need has to come from cities. They produce 60% of our emissions. And as I said earlier, the decisions we make in the next 2 or 3 years will basically set the path for the second half of this century. But to be realistic, and I'm presenting a version of this talk tomorrow to a whole bunch of the councils that are in our Cities Power Partnership, because it's at local government level where the adaptation rubber really hits the road. It's local governments that do adaptation. I think if there's one message from the IPCC report, other than being overall a pretty depressing document to read, is that it's probably cloud cuckoo land currently to assume that we will keep to 1.5 degrees. I hate to have to say that, but I mean, all the evidence is there that we won't. So we do actually need to plan at least for 2 degrees in terms of adaptation, and to do otherwise would be unrealistic and irresponsible. And then I just want to end with a little plug for the Climate Council. I know many of you follow our Facebook page and websites. We recently celebrated our 5th birthday. We were, of course, created after the Climate Commission was abolished on the first day of the Abbott government. I do like to point out that we have outlived the Abbott Prime Ministership I did actually count up exactly how many days, and I can't remember how many, but it was nearly 1,200 days, so we're quite happy about that. We've now produced just over 100 reports. Our next big report will be on water security. Lots of videos, lots of shareable stuff. We've got well over 200,000 Facebook followers, lots of Twitter followers. Since we've started, we've had over 28,000 media items, and we have a potential reach through our social media and media of 8 million people every month. So for those of you that have supported us financially, a big thank you. We hope to still be around in 5 years' time, but it would be nice if we weren't needed in 5 years' time. So I'll leave it there, and happy to try and answer questions. Thank you.
Thank you very much for coming down, taking time to come down and talk to us a little more. This is a very succinct summary, and I like the way that you zoomed across the top of all the depressing stuff that we know, but it's, and then you gave us reason for hope at the end. That's very good. I did look on the Climate Council site in a bit of detail, because Lesley was coming. There's really a lot of good stuff on it. So do have a look, and do have a donation, put a donation for you. So can I open the room for questions? Not conversation, so the question is one question, answer, and then another question. Thank you.
Last Monday there was a dubious claim on Q&A that previous reports have been found to be missing, failing in what they explain. Could you comment on that?
The IPCC, and okay, so I'm an insider on the IPCC because I have been an author on two of the assessments, not on this recent one. I think the IPCC reports are the most rigorously put together and reviewed documents of any document in all of history. I think Colin who's had a lot of experience, probably more than me, would agree with that. Each of the assessments is about 700 or 800 pages long. They have thousands of authors. They go through about 5 reviews. They receive thousands of comments, and every single comment is responded to in writing, in public, and you can go and look at all the comments. Having been through that process, it is extraordinarily rigorous. There's no other scientific or any other document, I think, ever written that is so scrutinised and so reviewed. That's the plus side. I think on the negative side, and I think this is probably some of the criticism of this latest report, is that the governments fund the IPCC through the UN. The summary for policymakers, which is the summary document that's produced from each report, is gone through line by line at a plenary session of representatives of those governments, and every single line must be agreed to. Now, of course, when you've got a committee that is functioning by consensus, it is inevitable that some of the more extreme statements or extreme views tend to come back towards this. It's the central limit theorem. And I think there are some scientists, especially in this last report, that feel that despite the fact that I've presented some pretty depressing stuff there, that it should have actually been even stronger than what was presented. So all I can say is, as a former author, while there's always room for error in any document produced by a human, it is quite an extraordinary process when you see it on the inside, and I have absolute faith that, at least at the general level, they have a lot of veracity. And I don't know who it was on Q&A, but one of those.
So you said there was we need an unprecedented change in the system. I just want to know if there's any research or if you have any idea of where the avenues for change should come from.
Well, there are going to be multiple avenues. So, I mean, we need to move to 100% renewables very, very quickly. We need to, phase out fossil fuels very, very quickly. We need to probably eat a lot less meat. So I see all the vegetarians in the audience are nodding, because meat has very large emissions, meat production. Agriculture, of course, is harder to reduce emissions from than some of the other sectors. So we need to be managing our land and our soils to maximise carbon sequestration. All sorts of things. We probably need a reduction in population. That would probably help, but human populations are probably not level off till about 2050 at about 9 billion. So we've got a couple of billion to go, so that won't help. But yeah, basically everything. We need to shift to electric transport and decouple transport from the grid, and then produce that electricity via renewables. Transport in Australia is about 12%, I think, of our emissions. So yeah, we need to do absolutely all of those things, and all of them as quickly as we possibly can.
And that's all outlined in the report, so.
Yeah, a lot of it is, and in previous reports. So in the IPCC, every IPC large assessment has 3 working groups. The working group 1 does the climate science. Working group 2, which is what I've been involved in, looks at the impacts and vulnerability, and working group 3 looks at mitigation. So the working group 3 reports are all about how you do it.
So we all know what has to happen. The thing that concerns me is that how many people are here tonight? 8?
I've had smaller audiences.
But how can what's the best way that we can go forward to get more people involved? Because I feel that politicians to change their minds, they have to feel that there's a groundswell.
Yeah. Look, it's really interesting. I think there is a groundswell at the moment. We were talking earlier. I think it'll be very interesting what happens this Saturday in Wentworth. Very interesting. I've been actually working with the Phelps campaign on their climate policies, and I'm pleased to say that they're very strong, even stronger than I thought they would be. Most surveys of attitudes to climate change in Australia in the last couple of years have put concern about climate change at well over 70%. So I think it is an issue where the mismatch between community sentiment and current government policy is very vast. You know, I think there's a huge discrepancy there, and I certainly hope that will be evident at the next election, and certainly I hope it'll be evident on Saturday. Look, I think there's lots of people in this room involved in lots of groups, and I see familiar faces all the time that are doing a tremendous amount. And we've just got to keep doing that. What can I say? I mean, I spend as much time as I can not doing my day job and working for the Climate Council. That's all I can do. Yes.
8 years ago, or 7 years ago, I listened to you talk about the green economy and Wollongong was going to be the green city. Has there been any progress?
Well, you guys are all in Wollongong, so I don't know. As I said, Wollongong Council is not yet a member of our city's power partnership, so a bit more pressure on them to do that. And I don't think Shell Harbour is either, somebody might correct me, though the rest of the South Coast are all members. Sorry? Were you going to comment about Wollongong Council? Or I'll just finish this question. I don't know, you guys are the experts of what's happening in Wollongong, I'm not. So there'll be other people that can
Can I have
answer.
a quick explanation of all this?
Yeah. Yeah.
Our carbon footprint was started by Thomas and John Garrett. And I'll give you a clue who his great-great-grandson is, Peter Garrett. And now I've been lobbying Peter and the others to now transform our city into a smart high-tech eco-city.
Yeah.
So I've been working on the green job stuff, and it was a political grab of my ideas and run by someone else, but it didn't really come up with anything.
Yeah.
But I'm happy to say it's nearly coming together now. So
That's great. Look, I think, yeah, I've been working on climate change. I've been doing research on climate change for about 25 years. And, you know, compared to when I started, there's extraordinary stuff going on now. It's much slower than we'd all like, but I think it is increasing exponentially. So, you know, I'm certainly hoping, and we have to hope, because otherwise we give up, that this exponential increase, both in concern and desire to do something, and coupled with technology and you know, economic
It's a
models and
political
all of that.
will.
Yeah.
Well, if you don't have the political will, it won't happen because you've got to make the decisions.
I think there are certainly elements in the political parties, not in the one that happens to be governing at the moment. But certainly, you know, Labor's climate policy is much stronger than the coalition. The Greens will, you know, we all know that they're very strong on this stuff. I think it's been really interesting that with this by-election this weekend, climate has been such an important issue. We'll see how that plays out. I'll be watching very closely.
Here on the news, often the economy is going okay. You know, 2% at the moment, or roughly that, and it's put in such a way that we can relax because it's increasing. What's the relationship between that increase and global warming?
Yeah. Well, unfortunately, it's pretty well correlated, though not completely correlated. So between 2014 and 2016, global emissions levelled off. And everybody got very excited because the global economy was still very strong during those years, and it looked like it was the beginning of an uncoupling. And everybody thought, this is it, this is peak. Unfortunately, in 2017, emissions went up 2%, and they'll probably have gone up another 2% this year. So there seemed to be an uncoupling for a few years, and then it wasn't. A lot of it is driven by how well the Chinese economy is doing. Though Chinese imports of coal are declining, and their renewables, they're investing very, very strongly. So, we just have to watch and wait, I suppose. But yes, there is a very strong correlation between economic growth and emissions, and that's why it's so important to decouple the economy from fossil fuel. Yep.
How with citizens' climate lobby? So in terms of what we can do, I guess it's influence Wollongong Council, get our friends to influence Wollongong Council.
Yeah.
My question,
Get on Wollongong Council.
to get on the city our partnership.
Yep.
My question is, could you tell us a little bit more about the city power
Sure.
partnership and
Yep.
what it's achieving for us to sell it to Wollongong Council?
Yeah. Well, the Cities Power Partnership was a sort of, it was actually a bit of a brainchild of Tim Flannery. And in fact, it came about when Tim and I were up in Bundaberg about a year and a half ago, launching our agriculture and climate change report. And we met with the mayor of Bundaberg, who was just fresh into office, who was one of the most, his name's Jack Dempsey, and one of the most enthusiastic people I've ever met. And he's an absolute advocate of renewables and transforming Bundaberg Council. And we came away thinking, local councils have got such an important role to play in this. There's about 574, I think, local government areas in Australia. And it's an interesting, when you've got a national level where there's a vacuum of climate policy, what you've got to have is the sub-national levels stepping up. So we sort of came away from that thinking, well, what can we do to support councils like Bundaberg in playing their role and in a sense stepping into the vacuum that is the federal government policy. So as many of you will know, the Climate Council is really a communication organisation, so this was a bit of a departure to support action on the ground. So we started talking to councils. The first tranche of the partnership was 35 councils. We're in launch 1, launch 2 was another 35, and we've just done the third tranche, so we're now at 101 councils, so about 20% of all councils in Australia. What the councils get is that they sign up, it's free, they are required to make 5 pledges, and there's a whole list of pledges that they can make, and the pledges can be around sustainable transport or renewable energy or emissions reduction, a whole bunch of things. They have to commit to 5. They can commit to more if they want to, and in a lot of cases the councils are already doing these things. We then buddy the councils up with other councils. So, for example, small rural councils without much money, we buddy up with the larger city councils that, like Sydney or Sydney or Brisbane that have been going for a while, to get them to exchange ideas and to help each other. We provide them with a whole bunch of free analytical tools so they can monitor their emissions and monitor water use and all of that sort of thing. So it's basically a sort of a peer support group to start moving towards emissions reduction and all sorts of other co-benefits of more sustainable living. So, yeah, it's a peer group support system essentially. Doesn't cost the councils anything to join. We've got our first conference. It's where I'm on my way to tonight in Kiama for the next 2 days. It's being hosted by Kiama City Council. Our keynote speaker is actually a Republican mayor from the US who, despite being a Republican, is extremely strong on renewable energy. And he'll be speaking, and then a whole lot of the other councils will be there sharing what they've been doing. So it's really communication amongst the local governments to help each other get there.
Do you have any measure of how effective that's been for emissions?
Well, we've only been going for a year, so it started a bit over a year, July last year. Not all of the pledges are about emissions reduction. Some of them are about other things. I don't have the figures on me, but a lot of councils are doing things like pledging to put all council buildings with solar panels. A lot of councils are putting solar panels on their libraries and their swimming pool and the council buildings, and changing over to electric cars or providing electric charge points, all of that sort of thing. doing community awareness campaigns, doing tree planting. There's a whole range of things, and councils can choose the activities that suit their particular situation the best. But, you know, it's hoped that by sort of making sure councils don't feel alone in doing this sort of thing, sharing best practice and sort of geeing each other up, and introducing a bit of healthy competition as well.
Is ozone depletion a continuing factor in the climate change?
Ozone's an interesting one. So ozone in the upper atmosphere we need that because... Oh, that was a fire alarm, that wasn't me. We need it in the upper atmosphere to reduce UVB radiation and stop us all getting skin cancers. In the lower atmosphere, ozone is a component of photochemical smog, and it is a greenhouse gas. So we still need to control it in the lower atmosphere, but we need to keep it in the upper atmosphere. So the Montreal Protocol is the protocol aimed at reducing that, and that's been very successful. The ozone hole, it's not really a hole, it's a thinning, has been shrinking since the protocol came into action. One of the interesting things that I was actually just lecturing about this a couple of days ago is that when CFCs were banned under the protocol, one of the other gases that wasn't banned, which are HFCs, are actually quite potent greenhouse gases, and it wasn't sort of realised at the time. So there's been an amendment called the Kigali Amendment to the Montreal Protocol, which is now phasing those out as well. And collectively, it's been estimated that that's about 0.5 degree of warming that won't occur because HFCs will have been phased out over the next couple of decades. So there is a relationship there, but it's a complex one. Yes, you.
Lesley, I'm interested in your perspective as an academic. So it seems to me like academics as a purist in the group are all very busy people.
Mm-hmm.
And in your career, you seem to have straddled quite a few different roles.
Mm-hmm.
Local councils, IPCC, academic research. Where do you feel like you've made the biggest difference, and do you have any suggestions for other academics?
Look, I can tell you what I've enjoyed the most, and that's the Climate Council. So the Climate Commission, which I was on when it was started, was a fantastic opportunity, and I don't regret doing that for a moment. You know, when we started, there were 6 of us. We travelled all over Australia doing literally town hall meetings in town halls and RSL clubs and all sorts of things, just answering Q&A for people, as well as doing the reports and stuff like that. That was a fantastic experience. And we were funded by the government, so we weren't interfered with by the government. We had Greg Combay as our minister, and he was fantastic, but of course we couldn't actually come out very publicly and talk about policy. So shifting from the council to the from the commission to the publicly funded council kind of unfettered us quite a bit. So if I have to, I mean, I enjoy all the other things I do as well, like WWF and Wentworth Group, but if I had to pick my favourite, it would be the Climate Council, because I think it's just a very direct way of communicating with the public. That's what it's all about. It's about getting the public informed so they can make better decisions, and really, you know, the distance between academics and the public is very very narrowed due to that work. I mean, for example, during the Paris climate talks, the council got 10,000 emails, and they were all answered. Not by me, thank God. But, you know, that just shows that the community support for the council has been fantastic. I mean, just the fact that when we started, and if you want to see as I said, we've just had our 5th birthday, and we produced a little video for that birthday about how we started, and it's on the website. But we didn't know, you know, we had the plan to do it. We knew we were going to be abolished, so we already had a business plan before the election. Though I was still kind of shocked when they abolished us on the second day. In fact, I lost a bet with Tim because he said, I think we'll be abolished in the first week. And I said, no, I don't think they'd be that stupid. Shows all I knew. But, you know, when we started the council, we didn't know if we'd get $5 or $500 or $5,000, and we raised $1.2 million in the first week. So, and we're still going. So I think that is a measure of how important how much the Australian public wants an organisation to do what we do. And that's very important to me. So that's my favourite thing.
And the energy for 2 more questions?
Yeah, sure.
2 more.
I had the opportunity to attend a number of forums presented by the Great Barrier Reef Foundation at the end of last year. About 6 presentations were made. All of them dealt with adaptation. How, with the Great Barrier Reef, we need to adapt in various technological fixes and all sorts of things like that. There was no discussion of mitigation. And I just wondered, if you're prepared to give an opinion, why an organisation that's sponsored by the mining companies and the big banks should receive $400 million from the federal government.
Yes, well, I can't answer why that's the case, and I certainly wouldn't support it. I mean, I think I'm all for money going to conservation and climate change action and climate adaptation because we need it. I think we'd all probably agree that the process by which that money was delivered to the Great Barrier Reef Foundation, which is full of great people doing really good work, was a completely flawed process. I mean, I think we probably all agree about that. Look, in terms of adaptation in the Great Barrier Reef, there are certainly things that can be done to reduce or to increase resilience of coral reefs. If the water is clean, if there's not nutrient output that's promoting crown of thorns, that's eating lots of coral, all of those sorts of things are things that are doable. However, when you look at the spatial pattern of the bleaching in 2016-2017, the worst bleaching was in the pristine northern reefs that had virtually never bleached before that we know about, and that had the cleanest water because there's very little agricultural or urban settlement up there. So even when the reefs are growing in very clean, pristine environments, they still suffered, 70, 80, 90% bleaching. So it just shows that even if you reduce all of the other stresses, which is what a lot of the research on the Great Barrier Reef Foundation is aimed at, you get a really big heat event and you still bleach. So, adaptation is fine. I mean, I think there's a lot of work going into looking at the potential for genetic adaptation in corals. There's a bit of work going into looking at the potential for translocating warm-adapted corals into other areas to regrow reefs and that sort of thing. I actually think we should be putting down a lot more substrate down the coast for corals to colonise further to the south. I'm a big fan of ecological engineering to create habitat. I'm not a pristine wilderness sort of person, love pristine wilderness, but there isn't much left, so we've got to be a bit more imaginative. But I do think that our coral reefs are in incredible trouble, and no amount of money being thrown at the Great Barrier Reef Foundation without fixing the root cause of the problem is going to solve that.
Could you say something about how nations estimate their emissions and how reliable it is and what might get missed out?
Yeah, look, I'm absolutely not an expert in carbon accounting. I think there's all sorts of things that go into it. I mean, they'll be looking at energy production from different sort of coal-fired power stations, etc., and calculating that. They look in Australia at least at land clearing and estimate carbon emissions from that, as well as carbon sequestration from regrowth. So they'll be using remote sensing to estimate those sorts of things. They'll be looking at how many cars are on the road and what sort of fuel they use and adding all of that up. It's a pretty complicated process, and I'm sure there are, once again, like all of these things, assumptions that are made at various stages of the calculation. The government's own, it's interesting that the government's own figures show that emissions have been going up every quarter since the carbon price was abolished. So we're going up at about 1.2 to 1.5% a year. So the notion that our Prime Minister says that we're going to meet our Paris climate targets at a canter is just complete nonsense. It's cantering in exactly the wrong direction. In fact, the independent organisation Climate Tracker, which monitors countries' climate policies and emissions, has actually estimated that we will be probably 26 to 28% above 2005 levels by 2030 rather than below, which is our target. So at the moment, we're going in the wrong direction, and I think that's the thing that counts rather than necessarily getting concerned about the intricacies of the calculations, but they're complicated.
I think we might call it a
Call
night
it.
there. Thank you
All
very
right.
much. Professor Hughes, have a look at this audience. This is the biggest one we've ever had.
And they're paid.
And so your name and the topic has attracted these people, and I've seen some of the email responses. We're coming. There's quite a few uni heavyweights here from,
Oh, good. Hello, uni
from the
heavyweights.
appropriate. I don't know who they are. Welcome, uni. Yes, what an inspiring person you are.
Oh, thank you very much.
It's great to see, like this, you can see the gloom and doom and ways out of it, and it's inspiring.
So
to see.
people often ask me, well, are you optimistic? And I usually say, well, it depends on the day. But I do think that unless you have hope and optimism, you might as well just go home. I mean, even in the most pessimistic times, you've got to keep trying, because that's all we can do.
And I think that's the message that people came here to look for,
Yeah.
and I think you got it in spades. So thank you very much.
Thank you very much.